Section 8.4 is on rational expressions. A rational expression is the quotient of two polynomials. Basically, it's a fraction with polynomials as the numerator and the denominator. To simplify a rational expression means to divide out any common factors. In order to do this, you may need to factor the numerator and/or denominator. You also need to state if there are any restrictions on the domain. Are there any values that x cannot be? What value or values of x make the denominator 0? Let's take a look at an example here. Here I need to simplify 9x squared plus 6x divided by 36x plus 24 and state any restrictions on the domain. So the first thing I need to do is factor both the numerator and the denominator. And in this case, I can take a greatest common factor out of each. So on the top, I'm going to take out a 3x, and that leaves me with 3x plus 2. And in the denominator, I can take out a 12. And that's going to leave me with a 3x plus 2. Now I'm going to cancel out any common factors. Obviously 3x plus 2. Okay. Remember, you can only cancel things that are being multiplied. So notice that on the top it's 3 times x times the quantity 3x plus 2. So I can't just cancel like the 2 and the 2 and the 3x in the parentheses and the 3x in the parentheses. I need to cancel out the whole set of parentheses. And then over here I can cancel out the 3 with the 12. And so what I'm left with is x over 4. That's the simplified rational expression, but I need to go back to my original denominator and set that equal to 0. So don't worry about the 12, but 3x plus 2 cannot equal 0. So 3x cannot equal negative 2. So x cannot equal a negative 2/3. That would be my restriction on the domain. So simplified and the excluded value. Now to multiply rational expressions, we want to factor the numerators and the denominators, divide out any common factors, and then multiply as you would fractions. So here's an example. We need to find the product of x squared minus 3x plus 2 divided by x plus 2 times x squared minus 36 divided by x squared plus 5x minus 6. So let's factor everything that we can there. So on the top of the first fraction, I'm going to get x minus 2, x minus 1, and x plus 2 cannot be factored. On the top of the second fraction, I'll get x plus 6, x minus 6. And then on the bottom of the second fraction, I will get x plus 6 and x minus 1. Now I can start canceling. So I notice I have an x plus 6 and an x plus 6. Those can cancel. I have an x minus 1 and an x minus 1. And I think that's it. I cannot cancel x minus 2 and x plus 2 because they're not exactly the same. So my simplified rational expression is going to be the quantity x minus 2 times the quantity x minus 6 all over x plus 2. Now I need to check my denominator. So I'm going to take my original factored denominator. So even though I canceled out an x plus 6 and an x minus 1, I still have to consider those. So x plus 2 cannot equal 0. So x cannot equal a negative 2. Sorry about that. X plus 6 cannot equal 0. So x cannot equal a negative 6. And x minus 1 cannot equal 0. So x cannot equal 1. So these values here would be my restrictions on the domain. Remember, it's the original uncanceled factored denominator. Now to divide rational expressions, we're going to factor as we did earlier and then multiply by the reciprocal of the second expression. So here we need to find the quotient of 6x minus 3x squared divided by 36 minus x squared divided by x cubed minus 12 minus x squared minus 2x divided by x squared minus 5x minus 6. That's a lot of factoring, so let's get to it. On the top here, the first one, I could take out a 3x, and that's going to leave me with 2 minus x. On the bottom, I'm going to have 6 plus x, and 6 minus x. And I'm going to go ahead and do a couple steps at once. I'm going to multiply by the reciprocal, so that means I'm going to factor my x squared minus 5x plus minus 6, and that factors into x minus 6, x plus 1, over, and then up here, the first thing I can do is take an x out, and that's going to leave me with x squared minus x minus 2, which is going to factor into x times x minus 2, x plus 1. Okay, so I have a couple obvious things that I can cancel right away. My x plus 1s will cancel, and this x can cancel with this x, but notice that x minus 6 is not exactly the same as 6 minus x. What I can do is I can rewrite any subtraction that looks like it's maybe backwards or I want to flip it around. If I want to write this as x minus 6, I can do that, but I need to put a negative 1 out front. Here's why. Because x minus 6 is the same as negative x plus 6, and I can factor a negative 1 out of that and get an x minus 6 in the parentheses. So once I've done that, I can cancel this. Well, actually, I can turn that into that with that. Let's go ahead and do the same thing here. Let's turn this into a negative x minus 2, just because it kind of looks a little better. And then I notice that I can cancel that. I can cancel that with this x minus 2. And notice I have a negative over a negative. Those are going to turn into a positive. Wow, a lot going on here. So what are we left with? We are left with on top a 3, and on the bottom, I'm going to flip that around, x plus 6. Remember, you can do that with addition. So there is the result of my division. And now let's take a look at what our restrictions on the domain are going to be. So everything that was either in the original denominator or the reciprocal denominator can't equal 0. So let's just go ahead and make a list of those. So we'll start with x plus 6 cannot equal 0. So x cannot equal negative 6. Then what did I have? I had x minus 6 cannot equal 0, so x cannot equal 6. And let's go ahead with the factored one, or the multiplied one here. So x cannot equal 0. X minus 2 cannot equal 0, so x is not equal to 2. And x plus 1 cannot equal 0, so x is not equal to negative 1. Now, was there anything up here that I had? So that factored into x minus 6x plus 1, and I have those taken care of over here. So here are all of my excluded values or restrictions on the domain. So in this section, we took a look at how to simplify rational expressions and how to multiply and divide them. Remember that before you cancel anything, you have to factor first.